Good morning, Principal Ma'am, teachers, and my dear friends. Today, I am going to present a presentation on topic ionization energy. 118 elements are arranged in periodic table in very systematic manner. There are some properties which are related to these elements. This defines the way in which these elements react. Since the elements are arranged in very well organized manner, even these properties follow some particular trend. Let's see how. One such important property is related to the elements, that is ionization energy, and it also known as ionization potential. Ionization energy is an energy which requires to remove the electron, so that electron is revolving around the nucleus of the atom, so that the electron, to eject the electron from there, to remove the electron from there, we need some energy. This energy requires to remove the electron from the nucleus of gaseous atom and converts it into a positive charged gaseous ion. Gaseous ion because we have a gaseous atom. That gaseous atom is there due to the electron is isolated, so that ionization energy is required. M is an atom which provides ionization energy, and it helps to remove the electron from M. When the electron is removed, we will left with M positive. Let's see how ionization energy varies in periodic table. We know that atomic size decreases from left to right and atomic size increases from top to bottom in the periodic table. When we move from left to right in a period, atomic size decreases. It means that outermost shell electrons are pulled with a great force towards the nucleus. Since the outermost shell is very close to the nucleus, so it's required a great energy to remove the electron from the outermost shell. So ionization energy increases from left to right. Let's revise how ionization energy varies in period. We know that on moving left to right, atomic number increases. Hence, atomic number increases, there is increase in nuclear charge of an atom. This increase change tends to pull the outermost shell towards the nucleus, due to which atomic size decreases. As the atomic size decreases, electrons are held tightly to the nucleus. Therefore, we need more energy to remove the electron from the atom. Hence, energy required to remove the electron is increases. Therefore, ionization energy increases. In neutral atom, we take magnesium. Its configuration is 282. In neutral atom, number of photons is equal to the number of electrons. So this is for magnesium. Now, if we remove one electron from magnesium, we get positive charged magnesium, which has electron configuration 281. Now, in this case, number of photons is one more than number of electrons. It affects the nuclear charge, which is exerted by this nuclear on the electrons increases. Since the photons now more, it exerts great pull on the electrons. So overall charge is that size of cation increases. Cations are always smaller than the neutral atom. Let's see. IE1 is the amount of energy required when we are removing the electron from the atom, and IE2 is the amount of energy required when we are removing the second electron from the atom. So what do you think? Is IE2 more than, less than, or equal to IE1? Let's see. We know when we move from left to right in a period, atomic size decreases, due to which ionization energy increases. And right now we see that cation size always smaller than the neutral metal atom. Since the cations are always smaller, so whenever we remove one electron, so the size of IE2 is less and the size of IE3 is more smaller. As the size decreases, ionization energy increases, because as the size decreases, the cations are outermost shell come more closer to the nucleus, so it is very difficult to remove the electron from there. So successively ionization energy value increases. What happens when we move in group top to bottom? Atomic size increases. This leads to great distance between the outermost shell and the nucleus. So the outermost shell and the outermost electron needs less energy to remove. So then ionization energy decreases in the down the group. Now let's revise how there is a change in ionization energy when we move from top to bottom in a group. The nuclear charge increases and then number of shells also increases. The increase in nuclear charge has an effect to tends to pull the outermost shell closer to the nucleus. Increase in a number of shells in a group. Atomic size also increases. As the atomic size increases, electrons held loosely. Since the effect of electrons on the outermost shell decreases, to remove the electron easy. As now electrons are easily removed, we need less energy since ionization energy decreases. To understand the topic more clearly, we are going to do some examples. So we have three elements: beryllium, magnesium and calcium. Let's try to arrange in the group. We have beryllium, magnesium and calcium be in same group, that is group number 2. We see the value of ionization energy from top to bottom in a group decreases. So these be in a particular group from top to bottom ionization energy decreases. So calcium is less than magnesium is less than beryllium. So it is clear that beryllium has high ionization energy.